Hello class, this is the third video covering activity 5.3. So far we've learned to reduce a rational expression, right? Simplify or reduce. Then we learned how to multiply rational expressions. And now the next thing we're going to do in this section is divide, okay? So, they ask us to remember that when dividing fractions, well, it's really multiplication, except we take the reciprocal of the second fraction, right? So when you look at their example 4, right, we have x squared minus 4 over x minus 3 divided by 5x minus 10 over 8x minus 24. Essentially, we just multiply the second term. So to do division of fractions or rational expressions, we take the reciprocal of the second term. What's the reciprocal? Well, that just means we flip it, right? The denominator now goes on where the numerator was. The numerator is now replaced by the denominator, okay? So essentially, right, we're just swapping places here, okay? So you'll notice that the 8x minus 24 now is on the top, and the 5x minus 10 is now on the bottom. Okay, and now this now becomes a multiplication problem, right? Notice how the division sign has become a multiplication sign. Right? We know how to do that. That's what we did in the last video, right? So once we've done that, right, we factor the numerator. So x squared minus 4 becomes x plus 2x minus 2, right? This is the difference of two squares. X minus 3 stays where it is. On the top, we have an 8x plus 24. We can factor out the 8. And you're left with x minus 3. And the denominator, you can factor out a 5. And you're going to be left with 5 times x minus 2. Now, the great thing is we can cancel the x minus 3s, the x minus 2s, and you're going to be left with 8 times x plus 2 over 5. All right, so here's the work where we're canceling everything. And you're left with 8 times x plus 2 over 5, okay? So let's practice right away. Let's practice some problems, right? If you look at number 13, all right, well, right away, I can factor out a 2, and I'll have x plus 3, and the 5 stays where it is. Now, I want to take the reciprocal here, all right? So that means put the 10x up on the top, whoops, and the x plus 3 on the bottom. Right? And notice my sign changed from division to multiplication. Right? So we take the reciprocal of the second fraction, change the sign from division to multiplication, and then cancel where you can. Right? I could cross cancel the 5 and the 10, or I could simply write 20x over 5, which we know becomes 4x. Final answer. Okay? If we look at number 14, okay, so the first fraction we can factor out at 2, and I'm left with t squared minus 9 over 7. But remember, t squared minus 9, right, this can be written as the difference of two perfect squares. So I can write 2 times t minus 3, t plus 3. And the 7 stays on the bottom. Okay? Now, to change the division sign to a multiplication, we need to take the reciprocal, right? The 49t on top and the t plus 3 on the bottom. Okay? So I'm going to write that here. And hopefully I can write this a little bit neater. And that's over t plus 3. Now let's cancel, right? T plus 3, cancel that. You could cross cancel the 49 and the 7, right? If I cross this out, that becomes a 1 and that becomes a 7, right? Because 49 over 7 is the same as 7 over 1. And you're going to be left with 14 t minus 3. I think that's it. There's nothing else on the bottom, right? right? So the 7 times the 2 is the 14, and t minus 3. So I can put this over 1, or really just write 14t minus 3. That's my final answer. Okay? Let's move on. Let's try number 15. And I'm going to erase some of my work over here, right? So we've done 13, 14. Let's do number 15. So number 15, we can factor out a k. And I'm going to be left with k minus 3. And the denominator, we can factor out a k. And I will be left with k minus 4. So the first fraction is done. To change it from division to multiplication, we take the reciprocal. Right, so the 4k minus 16 will go on the top, and the 3k minus the 9 will go on the bottom. And now factor, right? So if I factor a 4, you're left with k minus 4. And on the bottom, we factor out a 3, and we will be left with k minus 3. Now look, k minus 4 will cancel, k minus 3 will cancel, the k's cancel, and it looks like you're left with just 4/3. Okay, let's do one more. Let's scroll down to number 18. All right, so we have a trinomial on the top, right? So that looks like that's going to be one of the what two numbers when multiplied leave me with negative 21, but when added leave me with positive 4. So I'm thinking 3 and 7. So negative 3 times positive 7 results in 4. So the first fraction is going to be x minus 3, x plus 7. Okay? And that's coming from here, minus 3 and 7. The denominator has a negative 12, right? What two numbers when multiplied result in negative 12, but when added result in 4? So I'm thinking 6 and 2, right? A negative 2 times 6 will result in negative 12. And when I add them, I have 4. It's a little sloppy. So in the denominator, we can write x minus 2 and x plus 6. To change this into multiplication, we have to take the reciprocal. All right, so if I put the 6y on the top and the 4y on the bottom and then factor, we end up with something like this: 6 times y plus 6, and I factor out a 4, and you're left with y plus 7. And again, what can cancel? Okay, we have an x plus 7. Oh, by the way, you see what I did? I goofed. These are all y's, and I wrote the letter x's. So I used x all the way through, and I really should have used y's, right? Take a look, right? There's no x in the problem. So I'll leave everything in x, and then I'll change the variable from x to y when we're done canceling, right? So we have x plus 7, they cancel. X plus 6, they cancel. So it looks like we're left with 6 times x minus 3 on the top, and 4 times x minus 2 on the bottom. So the 6 and the 4 can reduce to, I guess, if we divide each piece by 2, you'd have 3 halves, x minus 3, x minus 2. Now, again, I made a mistake. I used x instead of y. So if you wanted to stay consistent with the y's that they use, you could write 3 times y minus 3 over 2 y minus 2. All right, see, I made the mistake. They gave it to me in y's, and I used x. Okay? I think that should do it for this video.